All right, so it says for the given statement, write the if-then form, then the converse, then the inverse, and the contrapositive. So if your statement is sophomores take driving lessons, how do I put that in if-then form? Go ahead, Mateus.
If you're a sophomore, then you take driving lessons.
Okay, if you are a sophomore, then you take driving lessons. Something like that. Doesn't have to be exact. Then you.
Sophomore, you take driving.
Then you do the then.
She's not wrong. You do. Okay, so you need an if-then. This is a new one. All right, so then the converse would be what? Go ahead, Sophia.
If you take driving lessons and you're a sophomore.
Good. If you take driving lessons,
That's not true.
that didn't say it was true, then you are a sophomore. Remember we said these aren't necessarily true or false? It might ask you to determine if they're true or false, but for now you're just writing. How about the inverse? Go ahead, Sophia.
If you are not a sophomore, then you don't take driving lessons.
Good. If you're not a sophomore, then you do not or don't take driving lessons. And contrapositive. Go ahead, Nick.
If you're not a sophomore, you don't take driving lessons.
So you need to switch the order and change it. So switch the order. Like you can either take the converse and put the nots in, or you can go back to the beginning, switch them, and say no. So the then becomes the if. So the driving lessons goes first, then the sophomores, but you negate both. So if you are not taking driving lessons, or if you didn't take driving lessons, something like that, then you are not.
Is this how the quiz is going to be?
There will be something like this, but there's obviously more. We're going to go all the way to 2-3.
To what?
2-3. All right, so then 2 says decide if the statement about the diagram is true and explain. Ray BD bisects angle ABC. True or false? Sophia.
True.
True, and how do you know that?
Because bisect means it like cuts right in the middle, and the
Congruency marks.
Yeah.
Yep. Okay, so A, B, D equals angle DBC, or the congruency marks show they're equal, or it shows that they are in 2 equal parts. Like anything like that would be your explanation. Santi.
On the test, we have to explain.
If it says the word explain, yep.
How are we getting?
We haven't even gotten to your test yet.
That means
Yeah, but there will be times in which you are explaining for sure. All right, 3, rewrite the definition as a biconditional statement. What has to be in a biconditional statement, Sophia? If and only if. So 2 angles are supplementary angles when the sum of their measures is 180 degrees. Go, Santi.
2 angles are supplementary angles if and only if the sum of their measures is 180 degrees.
Good. 2 angles are supplementary. Angles if and only if their sum equals 180 degrees. Questions on any of that stuff? Okay, we're going to go into the notes for 2-2, and then if we've got homework questions, because we're on a shortened schedule today, we might have to save them for tomorrow, but remember that you can now go in and you should be able to see those right answers, okay? And you want to make sure that you're checking those first, see if you can catch your own mistakes, and then if not, we'll go over it. But we're going to flip-flop for today, and we're going to get into the notes for 2-2. So this is called using inductive reasoning. This is where a lot of logic is going to come into play. This is where those questions of like, are they true, or what can I determine from the information? All of this comes from inductive reasoning. A conjecture is an unproven statement that's based on an observation. So you're watching things happen, and then you make a decision based on what you're seeing. That's a conjecture. Inductive reasoning is that process of getting to that conjecture. It's the process that includes looking for patterns and making conjectures. So this might be something like, okay, last week or the week before, when every day there was a huge long line outside of school for you to pull in. What happened to that first bell most of those days? When it was really hard to get into school, yeah. They delayed that bell. So you see this happening for several days, and by that last day, you're like, okay, I see that long line. They're probably going to hold that bell. That is inductive reasoning, and that is a conjecture. It is not set in stone. We learned quickly that that didn't happen all the time, right? So it doesn't necessarily happen, but you're looking for a pattern, so you assume it happens, okay? It's like coming to my classroom and me standing at the door. I'm probably going to ask you for your ID, but it is not a rule that I have to stand there at that door and that I have to ask you for your ID. So it is a pattern that you're assuming is going to happen, okay? But it's not concrete. It's not a rule, okay? That's inductive reasoning that leads to a conjecture. This one says, describe how to sketch the fourth figure in the pattern and then sketch the fourth figure. So what's happening from figure 1 to 2 to 3, Santi?
It goes 2, 4, and 6.
You're cutting it, yes? You're cutting your circle into 2 parts, then 4 parts, then 6 parts. Okay, well, you can add more than one line, though, because we're going to have to, right? But yes, you're dividing all those parts.
Yeah, and then the fourth one would have 4 lines.
The fourth one's going to have, you're going to have more than that, right? Because we're taking and we're dividing them each.
We're dividing it into 8.
There you go. So if I took that diagram and I just divided it, so it was like this, rough sketch, okay? But I'm going to divide each of these parts. Again, everything gets cut in half. So I'm adding more lines. How many of those, actually, wait, sorry, no, 4 parts.
Yeah.
Yeah, just kidding.
That would have been like figure 18.
That's an awful drawing, but you get the point. Okay. And how many of those parts are colored in each time, Nick? 1. So I only need to color in 1 part. So I went from 1/2 to 1/4 to 1/6 to 1/8 being colored in. Okay, that is a pattern, so that is inductive reasoning. Example 2, describe the pattern in the numbers 5.01, 5.03, 5.05, 5.07. What's that pattern?
It adds 2 each time.
Good. Increasing by how much? 0.02. Write the next 3 numbers in that pattern. So what comes after 5.07? 5.09, then 5.11, then 5.13. All right, example 3. Numbers such as 3, 4, and 5 are called consecutive integers. Make and test a conjecture about the sum of any 3 consecutive numbers. So for this, we're actually going to have to figure out our own pattern. So we're going to start, and I'd start with the 3 that they gave you. 3, 4, 5. What happens when I add these up? Start with any consecutive. So I can go 1, 2, 3. What happens when I add these up? Pick another set. Let's jump a whole bunch. Start with 20, 20, 21, 22, 63. Let's pick another set. 11, 12, 13. Mm-mm.
No?
Nope.
That's what I was thinking.
What happens to 11, 12, 13? What happens when you add those up? 36.
You could divide all these by 3 though.
And what happens if you divide them all by 3?
You get an answer.
What's that answer? So 12 divided by 3 is what?
The number?
Oh, they're
4. 6 divided by 3 is 2. 63 divided by 3 is 21. 36 divided by 3 is 12. Do you notice anything happening there?
Oh, it's always the middle number. Oh.
Yup. So if it had asked to explain that, how would you explain that? So the sum of any 3 consecutive numbers equals the sum divided by 3. Well, not equal, sorry. Just kidding. Divided by 3 equals the middle number. So the sum of any 3 consecutive numbers divided by 3 equals the middle number. Questions on that one? So even though they were all divisible by 3, like that was a good observation, there was a more specific observation. All right, a counter example shows that a conjecture is false. So we just said this before. We said not all of these true statements are true. I mean, not all of these if-then statements are true, right? So how do I prove that an if-then statement is true? I have to provide something called a counter example. And a counter example that makes something, it makes the hypothesis of a statement true, but the conclusion false. So we want the first part to be true, but the second part to be false. And again, it's called a counter example. So in my if-then statement, if you live in Florida, then you live in Miami. Is that a true statement?
Yeah.
No. What makes it, well, give me a counter example. What would make that false? Sophia.
Oh, wait. Never mind.
Oh, good. So you want the first part to be true, so you want to pick a city in Florida, right? But not Miami. So Pembroke Pines, Miramar.
That's still not true, though. That's not true.
We're not making it true. We're making it false and providing examples on why it's false. So but you're proving that it's false by providing what's called a counterexample, something that makes the first part true. So if I live in Pembroke Pines, I do live in Florida, right? That part is true. So you want to live in Florida, but outside Miami. You could literally list any other city in the state of Florida, and they are all counterexamples. I don't know why anyone would want to live there, but people do. Yes. Now, if I flip-flop that, if you live in Miami, then you live in Florida. What's a counterexample to that? Anybody know it?
It's not.
So,
If you live in Miami, then you live in.
There's another Miami. Do you know it? Ohio. Good job.
Are you from Ohio?
Okay, there is a Miami that is in Ohio. So again, you wanted the Miami part to be true there. Okay, but it's Miami, Ohio. That's that hard that you have to know that specific? No. All right, here, try these. So what makes this false? What's an example?
If you add negative numbers, it'll be less than the original.
Okay, if you add 2 negative numbers, add 2 negative numbers. Okay, anything else? It doesn't have to be 2 negative numbers, right?
No, it could just be like 1.
You could make it like -5 and +3, right? Okay. Questions? So it could literally be a description like that where you're specifically stating add 2 negative numbers, or you could literally pick 2 negative numbers and add them, or you could pick a positive number and a negative number. As long as that negative number was bigger, it would be it. Okay, yeah.
We can literally just write like negative numbers.
Yeah, that's your counter example.
Oh, you have to write a sentence?
No?
Oh, thank God.
All right, deductive reasoning. So that was all inductive reasoning based on a pattern. Deductive reasoning is based on accepted properties and the laws of logic. So these are going to be based on definitions or postulates or theorems, things that have been proven to be true. All right, again, facts, definitions, and accepted properties. So the law of detachment, there's going to be 2 laws, law of detachment and law of syllogism. Law of detachment says if the hypothesis of a true conditional statement is true, then the conclusion is also true. So if the hypothesis or the first part of your conditional statement is true, of a true statement, sorry, is true, then the conclusion is also true. So two things have to happen here. The original statement has to be true, and then if that is true, then the if happens, and then you get to determine that the then would always happen. Santi.
It's literally just like, today's Friday, I eat pizza.
Sure. So if it is always true that you eat pizza on Friday, then your if-then statement is if it's Friday, then I eat pizza. And then today is Friday, then you will know that you are going to eat pizza, and that is the law of detachment. If the if and then is true, and then the if occurs, you know that the then will occur, and that is your law of detachment. So if you come in late, Mrs. Chris Weiser is going to send you to get a pass. You walk in here late, what's going to happen?
Pass.
I'm going to send you to get a pass. That is law of detachment, okay? Law of syllogism has two if-then statements. If this happens, then this happens. And if that happens, then this happens. So you merge the two together. So there will be two statements, two if-then statements with law of syllogism. So if you lose your ID, then your teacher's going to write you a demerit. If you get demerit, your parents are going to ground you. You lose your ID, what happens? You're getting grounded. You skip the middle part that repeats, okay? If you drink too much water, you're going to have to go to the bathroom in the middle of class. If you go to the bathroom in the middle of the class, you miss the lesson. So you drink too much water, you miss the lesson. Okay? But that is don't take it don't take that personally. You were just a good example, okay? That's law of syllogism. So for me, I think syllogism is a longer word than detachment, and it's like more complicated, so I need two statements. That's how I remember the difference between the two, okay? So you're going to get asked to determine if something is decided based on law of detachment or law of syllogism, and then you'll also just get a statement, and it will say use law of syllogism. You're going to try to prove me wrong. By the time that kicks in, the next class is happening. All right, so given true, again, they have to both be true conditionals in order to assume the end. But if it's Friday, then you go to the movies. If you go to the movies, you eat popcorn. Your conclusion would be, if it's Friday, then you eat popcorn. All right, example 5 says, if 90 degrees is less than the measure of angle R, which is less than the measure of 180 degrees, then angle R is obtuse. The measure of angle R is 155. Using the law of detachment, which statement can you make?
If 90 is smaller m, then r.
So I'll simplify that for you. It's saying that if R is in between 90 and 180, then it's obtuse. And then you're given that R is 155. So what do we know about angle R?
That is 155.
Well, I already know it's 155. What does that lead me to know about it? It's obtuse. Does that make sense? So if it's between 90 and 180, then it's obtuse. And then you're given that it's in between 90 and 180. So we assume that angle R is obtuse.
That's all you would have to write?
Yep. And that would be law of detachment because it was just one if-then statement.
But can we just see that angle R is 155 degrees and just write it?
Yeah, but it's like, why do you know that? You know that because you know the definition of obtuse, right? Like if you didn't know what obtuse meant, you wouldn't know that. It's because you know the if-then of the obtuse that you know that.
Okay.
Yeah. And again, law of detachment is based on logic, like facts, which is a definition, stuff like that, which is something you already know. All right, example 6. If Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she'll drive to school. Now we're using law of syllogism. What can we make? What statement can we make? Sophia.
If Janelle gets a job, then she'll drive to school.
Good. If Janelle gets a job, then she'll drive to school. So if we look at these two statements, if she gets a job, she can afford the car. If she can afford the car, she drives to school. We are literally removing the repeated part and merging the other two together. All right, now we're saying, is this law of syllogism or is this law of detachment? You get an A on your math test, you go to the movies, you can watch your favorite actor. You get an A on the math test, you can watch your favorite actor. Sophia.
Law of syllogism.
Good. Law of syllogism. 2 if-then statements put together. Example 8, if x is greater than 12, then x plus 9 is greater than 20. The value of x is 14, therefore x plus 9 is greater than 20. Syllogism or detachment? Detachment. Law of detachment. And now we're doing inductive reasoning or deductive. Remember, inducting based on patterns and observations, deductive based on definitions and facts. Each time Monica kicks the ball up in the air, it returns to the ground. So the next time Monica kicks the ball up in the air, it will return to the ground. Is that deductive or inductive? Inductive, because we're forming an opinion based on patterns and behavior that we're watching. All reptiles are cold-blooded. Parrots are not cold-blooded. So Sue's parrot is not a reptile. Deductive, that's just science, right? Based on the fact that cold-blooded.
So could A be deductive too, since like the law of gravity is...
If it started talking about the law of gravity pulling the ball down, now you're talking about fact. But this is just an observation watching something happen, so we assume something. Yep, good question. All right, homework tonight is back on big ideas. Again, remember, if there's any kinks, we need to work them out. I emailed a couple of you over the weekend because I got the password sent. You need to make sure